Assalamu alaikum. This is Adib Mohammed Asif ID 1006185. Today I'm here with the presentation of the assignment of EEE 303. Moving on to the assignment questions. In the question number one, we can see that we are needed some parameters x, y, and t which are related to our student ID. So we found out x, y, and t according to the examples given in the question. And moving on to question number two, we are asked to design a Verilog module using some fixed specifications. The Verilog module have some inputs, have some outputs. The question is self-explanatory, and we will write our Verilog code according to the question. We will be using EDO Playground to design this Verilog module and run the test bench further. So moving on to the EDF diagram, at first we named our module as SN303. We have declared the input, outputs, and the required and necessary register type variables that will be used in our code. At first, we will satisfy the clock independence condition as it is written in the question that if s equal to 0, the output will be a high impedance state regardless of the value of the clock. So we will always define this at first so that the output is always a high impedance state when the value of s equals to 0. Then moving on to the next part of our module, we can see that there are some conditions given. So the conditions are clearly self-explanatory, and we will be using conditional statements we will be using case statements and conditional statements commonly to meet the requirements of the module. And as we were asked to store the value of m, so we have stored the value of m in another variable m in, which is used to store the incremented value of m. And as there are nothing said about what will be the states after the value of m greater than 16, so we have assumed the state to be again 0. Now moving on to the question number 4, we will be designing a test bench which will implement the module. So we have designed the test bench. Here we can see that we use the necessary protocols to write down while declaring the variables of the test bench, and we according as a requirement of the question, we initialize the value of m in our test bench. So the test bench is clear, self-explanatory, and we have run the test bench by setting a clock for s and I, and we have run it for all the possible combinations of a, as there were nothing said about the value of a in the question. So we will be testing for all the binary combinations possible for 5 bits. So after running, our output kind of looks like this. So the output is also self-explanatory. When s equal to 0, the output is a high impedance state, and so on. So the output will be more clearly visible if we go to the waveform format. So we can clearly see that when the value of s is 0, the output is a high impedance state, and other necessary conditions are also prevalent in the output. And the output, while clock jumps to 1, the output uh, responds accordingly. We can see clearly from the output. So now moving on to the next question of the assignment, we have to design another test bench that would take sequentially the values of that would take sequentially in each clock pass in a repetitive manner. Modify the test bench in question number 3 so that the Verilog module is given the digits of x sequentially in each clock pass. So what I understand through this is I will sequentially input my student ID in the test bench. So my student ID is 0106185, and this is considered to be hexadecimal as stated in question number 1. So the first output will be 000005. Now let's see what happens. So we have written the test bench for the problem, and we have declared 3 extra variables: x actual value, x temporary value, and x input. We have set x input to 0 and the rest others to the x temporary value, which is my student ID. And the initialization is kind of similar to the previous test bench, and just we are to initialize the value of x in this test bench, which is an extra work here. And for s and I, we will do the same thing as done before. Now we will go for all the 32 possible combinations of A, and after that we will be updating the value of x. At first, the value of x will be the last 4 bits of my number, that is that will be necessarily 5. So that this thing will be more clear when we will analyze the output. Then we will update the input and the temporary value. And if the temporary value becomes 0, then we will again set the temporary value to the actual value and run our code. So after running this, let's see what happens. So the code will run for 128 seconds at time 0. It is obvious that the 0 value will be in the input of the module. So after 1 second, in the first second, the value of x, that is equal to 5, 0, 0, 0, 0, 0, 5 in the first second, then 0, 0, 0, 5, 8 in the second, and so on. As the least significant bit of my number student ID is 5, so that first the least significant, then that, and so on. The in this order the input will be will be considered in this test bench. So let's see the EP waveform format of this output, and we can see that the EP waveform format is also self-explanatory. So here from we can draw the conclusions that our assignment, my assignment is successful to meet all the requirements of the requirements of the questions. So thank you very much. Assalamu alaikum.